Welcome back. Let's have a look at another thing we can do with compound interest, and that's working out the interest rate that it'll take for an investment to grow from one amount to another over a specified amount of time. So let's have a look. That's a pretty typical question. So we may know the present value and the future value we want to get to. We may know how long we have. The question is, what kind of rate will it take to make all of that work out? For example, what rate of interest would it take if I wanted to double my money in 10 years, right? We'll come back and look at that one in a little while. That's a type of question we want to be able to solve. Here's how we work on it. The formula for I, again, is based off of the original future value formula. So let's start with that. Future value, present value times 1 plus I to the power of n. Well, first thing I'm going to do is divide both sides by present value. That leaves me 1 plus I to the power of n on the right-hand side. Now, I know n. I'm trying to solve for I. So in this case, I'm going to take the nth root, it's called, of both sides. That's going to give me, over here on the left, future value over present value raised to the power of 1 over n. And on the right, I end up with 1 plus I to the n over n. Well, n over n is really just 1, isn't it? So I can just cross that out. So I've just got 1 plus I over here on the left now. I can subtract 1 from both sides, and I get future value over present value, power of 1 over n minus 1 equals I. And then I'll just go ahead and flip it left for right, because we usually like the unknown thing on the left. I get future value over present value, power of 1 over n minus 1. That's our formula for I that we're going to use. Now, I'm not going to show you one first. I'm just going to let you jump right in and try it out because you're probably getting the hang of these things. So what I'm going to suggest is you read through this one. This goes back to that very first question I asked you a minute ago, saying what interest rate will we need if we want to double our money in 10 years? In this case, though, I'm looking for the monthly compounded rate, or the J12. All right, so that's what we want to get out of this one. Let you hit pause right now, work your way through this one, and when you're ready, hit play again, and I'll go through it with you. All right, welcome back. So let's have a look. For these double type questions, it's nice to just pick some simple numbers like this. And for n, we have to keep in mind that we've got 10 years, but we're looking for the monthly compounded rate. So I have to factor that in. I've got 120 months here for this question. We want to work out what I is. Remember, I is the future value over the present value, power of 1 over n minus 1. In this case, that's just 2 over 1 to the power of 1 over 120. Now here's a little tip. You may find putting brackets around that makes it easier to enter into your calculator. So go ahead and do that if you're struggling with that. If I work that out, I get 0.005 792 941. That's the little I. That's the interest rate per month, isn't it? But we wanted the J12. So to get the J12, I got to take little I and multiply by 12, bring it back up to the whole year, and that's going to give me 6.95%. Pretty close to 7%. That's sort of a general rule in finance, by the way, with compound interest. If you want to double your money in 10 years, you're going to need about 7%, depending on how often it's compounded. That's it from now. Go back to the textbook, practice a whole bunch of these, try out different wordings on the questions and that sort of thing. And when you're feeling good and confident, come on back and we'll look at our next topic.